What up, YouTube? Welcome to a segment I like to call Granny's Couch with Ranham. So basically, it's in the dog days of summer here in Florida. The last 2 weeks, it really got hot and humid. And my one workbench is located out in the shed. My other workbench is located in my Florida room. And it's just way too hot to sit and do a flapping video. So the only other place I could think of doing it is on this couch, which is kind of embarrassing when you come from my house, and I get embarrassed that I'm not really that good at interior decorating, but the price was right, and it has a sleeper sofa in it, and I like to affectionately call it Granny's Couch, because it reminds me of a couch that you would see over your grandparents' house that you weren't allowed to sit on. But this is my house, my rules, I can sit on it. So I was putting together the part 4 of the electric skateboard project, and I had a lot of footage. I had footage for probably 8 different parts, and it was long and boring. And if you remember, when I left off in part 3, we were just getting ready to do the power up and do the Blackmagic smoke test. Now, unfortunately, there's no interesting footage there. There's no Blackmagic smoke. But that doesn't mean I didn't burn up things. So it's like I had the worst of both worlds. I burnt up stuff, but even though I was filming it while I burnt it up, it didn't leave any Blackmagic smoke. And basically, I powered up the system. Everything powered up fine. No problems whatsoever. And I started running the motors a little bit. Everything was fine. No problems whatsoever. But when you went full speed, it would just blow out. It blew out the gyroscope, and it blew out the microcontroller. So once I realized that the gyroscope and microcontroller were smoked, which, by the way, they didn't show any indication of being smoked, but they did short out. Like the I2C bus was shorted out, so I didn't have an LCD screen. But the LCD screen, OLED screen that I'm using was fine. It never, and that thing, man, for that OLED screen being like $1.58, I really put it through the ringer, because it didn't burn out at all when I was burning out the microcontroller and gyroscope. It accidentally worked its way loose and drug against the asphalt and actually sanded a corner down on the PCB and a little bit of the glass on the screen. And when I went and put heat shrink around it to put strain relief for the cables coming out of it, it like blackened the one corner of the screen, but it wasn't the corner that actually has the graphics. So man, that thing's like bulletproof. So anyway, I burnt out the gyroscope microcontroller, and I was like, what in the world is going on here? Really frustrating. I sat down, I thought about it, and I don't know, I changed something, but I went and I put a brand new microcontroller in it, which, by the way, I don't know if this is on the build video or not, but I ran out of 28-pin dip sockets. So I was like, why put a dip socket on a microcontroller? I've never replaced a microcontroller before. So guess what? I didn't have a dip socket on that microcontroller, and that microcontroller burnt out on me. So I had to remove that microcontroller. I did smarten up, and I had SIP sockets that I was using when I was using a 40-pin controller. I think it was when I did a project with the ATmega 644, possibly. And so I ended up using SIP sockets, 2 SIP sockets, to have the microcontroller on a socket. And good thing I did, because guess what happened? Oh yeah, and I didn't have an extra gyroscope. So the gyroscope was just removed and the code was removed. And guess what happened? I shorted out the microcontroller somehow. So I really sat down and I thought about it. And I know some people at work watch my videos, and you're probably going to really make fun of me and can't believe that this was the problem. But the problem was a ground loop on the PPM signal going from the vests, the VESCs, I left a ground run along with the PPM signal, and I also had a ground going through the 5-volt regulator. And apparently this was causing some kind of ground loop that when the motors were running at full speed would send a ground spike up through. Now, I originally left the ground in on the PPM signal because on quadcopters, that's what I usually did. But after thinking about it, on quadcopters, between the flight controller and the ESCs, both grounds, the power ground and the PPM ground, are usually in parallel. So even if there was a ground loop, they're usually connected at the same spots on the boards. Where on my design, the way it was soldered up, the grounds were kind of actually making a loop through the controller. So I'm assuming that those ground spikes were spiking out certain pieces of equipment. So what I ended up doing in the board, I was soldering a 30 gauge wire, got very messy. So what I ended up doing is I removed all 5 volts and grounds from the control board. And instead of piggybacking the 5 volts and grounds, all the 5 volts and grounds go straight into the 5-volt regulator. And then I added a low ESR cap that I had laying around for my quadcopters, and bam, that was it. No more ground loop problems. But that was only the first of many problems that I had. So let me think about what other problems. So finally I go to test drive it, and it's very jerky, very uncontrollable. Like, it would be jerky, and then you would have acceleration, and then it would start braking all of a sudden, and then acceleration again, even when you were holding the throttle still. So I traced that back to the controller I hacked up, and I was like, okay, so this hacked up controller doesn't work well. And another thing is, I had a big uh-oh moment that I didn't set the failsafe up right on the controller when I linked the transmitter and receiver together. So if it lost connection, it would go to 100% throttle immediately, which the board has so much torque that would throw you off the board. So I ended up doing emergency surgery on the remote that I 3D printed. I was able to go back in the previous video, able to see where the bind button was on the control board, was able to drill an access hole so I could short out that bind button because I removed that button. But I was able to short out that bind button, and then I was able to rebind it, and that solved my failsafe problem. But I still had a problem with just inconsistent PPM. And from troubleshooting, I thought that problem was the remote control. And I still believe that problem is the remote control, was just unreliable. So I ended up going and I just ordered another remote control, this one here, and I said, you know what, I'm not going to hack it up. I'm going to go and just use this remote control just to get this project running. Now, I did go ahead and order all the parts from AliExpress to make a Firefly remote, and that is going to be in the future. But with this COVID virus, the parts are taking a long time to come. I only had one part show up from AliExpress for that Firefly remote, but that's going to be long in the future. I'm just going to use this remote control because in reality, this remote control isn't really that bad to hold in your hand and work. So I got this new remote control, bounded it, bound the fail-safe right, and then had the same problems again. Now, it wasn't as bad. That's why I still think the remote control was part of the problem. It wasn't as bad, but it was still a problem. So then I ended up changing my game plan. As you guys know, I had dual PPM going to each individual vest. I removed that, and I went with a master slave over the CAN bus configuration. So I got all that set up, reprogrammed the vest for master slave, which I should have done from the beginning because it was a lot easier to do. And the way the vests sit in the box, the one you can get to the USB, the other one you can't. You had to unbolt the vest to turn it sideways to get to the USB. So I set up a master slave, and the master is the one that you can get to with the USB, so you can just access both with the one USB. And I tried it again, and it was still jerky. And I ended up tracing it back to the connector, the servo 3 header connector on the control board was bad soldering. It was a combination of bad soldering. I had a cold solder joint and a combination of pressure being put on that connector. So I ended up physically locating that connector to the edge of the board where there would be no pressure pushing on that connector. Got rid of my cold solder joints, and the thing is butterly smooth. I also changed the throttle curve a little bit. Just changed the throttle curve just a little bit, and it's butterly smooth. The board works great, and I drive it around. I just took it for a test run for 3 miles today, and the board worked great. I had no complaints about the performance of the board. The one thing that was never explained to me was that since these motors are not sensored motors, that even I thought hub motors were the only ones that had to be sensored in order to have the torque at startup. I was wrong. You do have to be going at startup before you give it power, or the motors won't torque. Now they'll run if no weight on the board. You give it power from dead stop, it will go forward. If you have weight on the board, it will not go forward. And it's literally the motors just have to be moving, just barely. If the motors are barely moving a little bit, then it'll be able to go. And it wasn't explained to me that even on a belt drive configuration, you have to have sensor motors. So that's something that I would do in the future, is have sensor motors. But no complaints there. You know, just give it a little push start, and board works great. So once I got through all that problems, I printed out a battery box. I installed a battery box. I installed grip tape on it. And as you can see, I put the grip tape over the threaded inserts, and which you'll see later. And so you only see the bolts for the trucks. And then this week, I went and I put a headlight on it under the front trucks here. So I actually removed one of the risers, and out of PETG, I 3D printed a riser, and the riser has this has it in it to attach the headlight, and the headlight is one of those freebie lights from Harbor Freight. I took the LED out, and I'm running it off of 5 volts with no current limiting resistor. I want to run this at night. It just rained. I don't want to run it with the roads wet. So maybe one night this week I can run it dry and see how well that headlight works. And the next part I'm going to focus on now is I'm going to make brake lights. I'm going to make brake lights out of super red LEDs that I already have laying around. So it won't be a single LED panel like the headlight, but it's going to mount to the board the same exact way through its own riser. And so far as I can tell, the PETG riser printed with 75% infill is a acceptable riser. It worked great. I do have some problems with the fitting of the lids that I had to change with the holes and the heat seat inserts. I've been watching a lot of Ben Heck videos, and Ben Heck does not use a heat set insert. He uses screws. But I commented on his video, hey, can you go and explain your hole diameters with the screw sizes you use? And no one ever responded that. If he could make a video explaining that. But the heat set inserts work great, but I did have 2 come out, so I'm going to have to epoxy them back in. And had a couple of revisions on the covers, but I finally got it to fit. They're not perfect, but they fit. And they look, oh look, this bolt worked its way out. That's the thing, these bolts will vibrate their way out. So I don't know if I need to just put them a little tighter or what. And but for my 3D printing design, the way they fit is acceptable, and I think it looks super cool. So I came up with the nickname Walnut Rider for the board, since I used dark walnut board. And then I put Ranham, and I made this nifty little graphic lipo inside. I was trying to think of something smart to put in on here, and I didn't want to do, I know some people do like 12S powered or 1400 watts. I thought, well, I just thought, well, there's lipos in there. So I came up with the idea, and I was able to put this graphic together. You can actually get that font, the Intel font. And bonus points if you know where this Walnut Rider font is. And I have the little OLED screen here. So let me turn it on. So when you turn it on, there's a weird thing that the microcontroller is like in a locked up state unless it receives the initial PPM signal, because the receiver does not output a PPM signal until it links up. And then now with the failsafe set right, when I turn the failsafe off, it just goes to 0 throttle, but it's still outputting a PPM signal. But without the PPM signal, the microcontroller just locks up. It has something to do with the interrupt. It needs the PPM signal. So anyway, when you turn it on, it's just ready to go. And I have the Walnut Rider graphic. Actually, let me zoom in on there. You see if I give it throttle, and that's brake. So a little PPM graphic, and as you can see, Walnut Rider. The one button, I just have it set to inverse the screen, just to make sure that button works. So here's what I ended up doing on the other button, if it doesn't trigger at all. Also, I had problems with random external interrupt triggers, and I ended up having to put an additional RC circuit on the external interrupt pins to prevent them from triggering. But while you're in this playback state, the only way that it will switch out of this playback or running state is if you go full brake and then press the black button. Okay, now we go to a little indicator screen. So as you can see, we have the ADC value, 12-bit value of the throttle, the PPM, and then we have the value of the battery. So as you can see, 48.375. So I charged this battery up to around 95%, and I ran it for 3 miles, and I'm at like 80%. And I'm gonna go and I'm gonna work on the programming a lot more, but to give me like battery percentages, so I don't have to calculate them in my head. It'll just tell me, oh, you have 80% battery left. But I'm just using this as a demo on the information. Now I ended up, there was only one IC that would accept the high 50 volt 12S battery, and I'll go and insert the model name of that ADC. And there was only one YouTube video with the Arduino library, and once again, I am not using Arduino. I'm programming it in Atmel Studio AVR GCC, but there was one YouTube video that informed me that, hey, there is an ADC out there that will accept 50 volts. And as you can see, I installed it in the board, and it works great. I haven't burnt it out yet. Now, if I go to the next screen, it controls the headlight. And I was going to put it on and off on the OLED screen, but I didn't do that yet. But anyway, the way I do that is through the throttle. So when I'm on the screen and I give it throttle, as you can see, the headlight comes on. And as you can see, I have the microcontroller disabling the PPM to the VES. So when you're on these screens and you use the throttle, we can use the throttle to select these different options on the lights and stuff, but it's not going to actually spin the motors. And when you go full brake, it turns the headlight off. So if I want to turn the headlight on, I go to the screen, give it full throttle, and then I press the go to the run menu and start running. Cool, so the next thing I'm gonna do is I'm gonna add brake lights, and then after that I'm gonna decide whether I'm just gonna go ahead and put the RGB LEDs on, which I think I'm just gonna go ahead and throw caution to the wind and put them on. And then once I have all the brake lights, the headlight, and the RGB LEDs, I can try to make some sort of wire harness and put it through fitting in between the battery here, which you can't see because of the covers. Anyway, that's the progress on my electric skateboard. If you watched this far in the video, let me know. I figured doing it this way was a lot better than watching me go through the struggles of, okay, I'm burning out the microcontroller, I'm burning out the microcontroller, my throttle's unstable, my throttle's unstable. So I'll end the video with a little montage of everything I have of putting this guy together. And we'll see you on the next video. Thanks for watching.
Thank you.